Welcome, everyone. Today we have Milica Gašić, currently from University of Düsseldorf, Heinrich Heine University. Milica has done quite a bit of work in the dialogue field, in particular looking at statistical methods for modeling dialogue. So she is currently a professor of dialogue systems and machine learning at Heinrich Heine University in Düsseldorf, and she focuses on questions of human-computer dialogue modeling and considers her work at the intersection of NLP and machine learning. Milica got her PhD at the University of Cambridge, and in fact got an award for her PhD. And over that time and since that time has been very active and has garnered really a whole list of best paper awards, which I will not go through all the acronyms for you, but she's made a really major contributions to this field. So without further ado, I'd like to ask Milica to proceed.
Thank you very much, Alex. And I have to say that it's really a pleasure being introduced by Alex, because on my very first conference attendance, I gave a talk at SIGDIAL and Alex introduced me, and I was really impressed that he could pronounce my name correctly, especially given that at that time, not even my PhD supervisor could pronounce my name correctly. So thank you, Alex, for that, and thanks for the introduction. So I titled this talk, 10 Things You Should Know About Dialogue. And I have to make a disclaimer, especially because this is going to be recorded. These are not the only 10 things you should know about dialogue. This is just some of my personal picks, and in particular, they are related to statistical dialogue modeling for two reasons. The first reason is that this is mostly my area of research. And the second reason is that I think this area of dialogue has seen the biggest transformation in the past years. So with that in mind, I'm going to start. I first want to say that dialogue actually is a core AI problem. And this was actually initiated by Turing in his paper, Computational Machinery and Intelligence, where he poses that we can only say that we solve intelligence if we can communicate to a machine without being able to say that we are actually communicating to a machine. So for those of you who haven't read the paper, I would urge you to read it for two reasons. I mean, you can see how imaginative Turing was in the way he posed this test, but also how grossly he underestimated the difficulty of this task. And he even goes on to say how much memory we would need to solve this task. And well, in fact, we have huge amounts of memory today, but we are still not there in terms of solving this task. And the reason is that dialogue is actually hard. There are infinite possible trajectories of system and user turns, and we can always think of a dialogue that was never produced before. And I guess this is something that is actually very related to the whole problem of modeling natural language. It's also fair to say that the dialogue is an AI complete problem simply because it encompasses solutions to NLP problems, which in itself are AI complete. So you can read more about that in Shapiro's Encyclopedia of Artificial Intelligence. But as I said, I'm going to pick 10 things that I want to talk about today. And the first one is basically, what is the point, or what is the point of dialogue? What I actually mean is the difference between those dialogue models which model a point or a goal of dialogue, the task-oriented dialogue models versus chat-based dialogue models which do not have a strict goal. It is fair to say that humans do not make a strict distinction between task-oriented and chat-based dialogues. However, modeling approaches do. So as I said, task-oriented dialogues typically have a goal or a number of goals that they model, and they only operate over a narrow, well-defined scope of conversation. Social dialogue approaches typically do not model a goal. They allow the conversation to span over a huge number of topics, and they don't necessarily pose a restriction on the vocabulary. On the other hand, they model emotion and sentiment. And today, the approaches are intertwined. And in my mind, I think that's a good thing. But on the way there, we might sometimes lose some aspects of task-oriented or social dialogues that are important to track. So just as two examples, I picked here Jupyter dialogue system, which is produced by Zhu and colleagues at MIT. That's a typical task-oriented dialogue system, so it's giving information about weather. And I've also picked Alexa challenge winning submission, which was work by Fang et al. At University of Washington, which is a social dialogue system. Now, these two systems are very different. They're built for a different purpose at different times, of course. But actually, you will, if you have a look at how they are built, you will find some similarities. They both encode some aspect of modular approaches to dialogue, which I'll talk about later. Now, when we talk about the goal or dialogue goal, this is very connected to the concept of ontology. So task-oriented dialogues typically interface a database, and the database is described by an underlying ontology. And the simplest ontology we can think of is a database of different entities that belong in different domains. And these entities have properties which we call slots, and these properties can take particular values. But it's important to say that this can be much more complex. For example, a knowledge graph, like the one, a snippet of one there is in this picture. Now, also what is important when we talk about goal and task-oriented dialogues, to think about or to know about dialogue act formalism. So there are very many ways we can say essentially the same thing. Dialogue act formalism describes meaning encoded in each dialogue turn, and as such has very strong relation to ontology. But it can also encode intention of the speaker. Is the speaker informing the system about something, or confirming or requesting particular information? It can also have relation to logic. There has been a lot of work, but maybe not sufficient, into how we can express more sort of first-order logic requests in dialogue. Also relation to context, because obviously that is important, and I will talk about it later more. And partial information from speech recognizer or primitive dialogue acts, because not in case you're talking about spoken dialogue systems. Today, with the advent of neural network approaches, this intermediate formalism is disappearing. It is somehow inherently encoded in the neural network, but nevertheless, I think it's important to be aware of it, so you know what is the capability of the dialogue system. Now, oops. Now, the second question is when to speak, or the concept of dialogue turn. Most of the time we think of a dialogue as a sequence of system and user turns. But actually, if you look at how humans communicate, this is a lot more fluid. So humans tend to interrupt each other, they hesitate during conversation. So we have these barge-ins and back channels. And for spoken dialogue systems in particular, it's very important to consider incremental dialogue processing. So here I picked two papers, Skans and Schlangen, incremental dialogue processing in a microturn, and Petzel et al. So which one is it? The effect of alternative incremental architecture in a high-performance game playing agent. The idea is that if you allow the system to incrementally process information, it will be more efficient in communication exchange. So the third point is context, 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 and I cannot more emphasize the importance of context. So there are three properties the dialogue system really needs to have. One is to understand the user, another one is to respond to the user, and the third one is that it needs to conduct conversation beyond simple question answering. And for that, it really needs to have a notion of dialogue state, because there are infinite possible dialogue trajectories, and the dialogue state summarizes what is important in the dialogue up to that point in conversation. So it needs to summarize the dialogue history, it needs to represent the user goal, it needs to contain grounding information. So if you're not familiar with the term grounding, you can think about the conversation between pilot and the ground control, and it's very rigid communication, but what's really important there is that both parties know what has been agreed upon. And in order to do that, you very often have to solve things like co-reference resolution. So here I have one book actually and one paper related to how to define dialogue state. But I'm just going to tell you a little more about approaches of how to track dialogue state, because dialogue state changes from turn to turn, and maintaining the dialogue state throughout dialogue is essential. And this is a supervised learning task. And popular approaches include Bayesian networks and more recently neural networks. But things to consider are how well the tracking performs on its own. Can it run real time? So can we actually use it in a real dialogue system? Does it support user changing their mind? And this is actually a question on which the generative or Bayesian approaches typically fail, because they do not readily support user changing their mind. And what happens when you introduce new values to the ontology? So just to answer that last question and go back to briefly on what I mentioned in the first slide, I'm going to review a recent work here, which is TRIPI, a value independent dialogue state tracker, which is built using state-of-the-art contextual word vector embeddings and span prediction. But in addition to that, it deploys a triple copy mechanism. And that means that the span can extract values directly from the user input, or a value may be copied from a system informed memory that keeps track of the system's informed operation. And this part is effectively doing co-reference resolution. So if the user is referring to something that system said, then we need to extract that part of the dialogue state from the system input. or a value may be copied over from a different slot that is already contained in the dialog state to resolve co-references within and across domains. So this is something that's more important for multi-domain dialog modeling. So this work achieves state-of-the-art dialog state tracking, but as you can see, although it's based on deep learning, it actually it relies on knowledge that was there long before the deep learning renaissance. So the fourth point I want to make is the dialogue is a game to play. So if I just recap on what I said, so if I here represent each circle with a dialogue term, this pair of system and user input in dialogue, and if we are at the moment here at the this is the current turn, tracking is effectively summarizing what happened before in dialogue. So it is summarizing the past. While at this point in dialogue, the system needs to decide what to do next in such a way that at the end of this conversation, the goal of the user will be fulfilled. And in order to do that, the system needs to perform planning. One particular way to achieve that is to model dialogue as an MDP, markov decision process, and utilize reinforcement learning. So this was actually proposed quite a while ago by Levin and colleagues in a stochastic model of human-machine interaction for learning dialogue strategies. The idea is that the dialogue can be defined in terms of dialogue states, system actions, and associated rewards. The Markov decision process postulates that the next state only depends on the previous state and action. And then the reinforcement learning is really an attractive framework for optimizing the dialogue policy. And the dialogue policy decides which action to take in the next dialogue state, and also steers the dialogue towards goal completion. So one problem that reinforcement learning has is that it is very slow in terms of learning, or that it requires more specifically, it requires many dialogue interactions. So in this work, we worked on speeding up that process of using alternative reinforcement learning mechanisms that allow to learn more efficiently. And we set up a system which was learning from scratch with human users. So the idea, we've set up the system on Amazon Mechanical Turk, given the users task to complete, and based on the feedback that we got from users, we changed the dialogue policy, and we found out that actually we can reach the performance of a policy trained on simulated user, but without the need to actually develop a simulated user, as this is something that is usually problematic in dialogue research, that you sort of need a simulated user to train your system, but then the question is, how do you actually build one? And is that simulated user really adequately representing user population? Now, the fifth point I want to make is, are you sure in the performance of your system, or actually how sure is your system about its performance? So here I have a list of state-of-the-art dialogue state trackers on the MultiVoice dataset, which is a multi-domain dialogue dataset that I'm going to talk a bit more in detail in a minute. But here they're scored according to the joint accuracy, which means that they are correct if they get prediction of each slot correctly. Otherwise, their prediction is considered incorrect. And if you see results, you can see that actually they are wrong almost every second turn. But because they are tracking dialogue state, that means that they put full confidence on their almost 50% of the time incorrect answer. And that's not good. So this was actually noticed long before, that it is important to consider distribution over possible states rather than simply try to model the best dialogue state. And this is something that was introduced as a part of the partially observable Markov decision process framework, where the idea is now that we have observations which represent what system hears, dialogue state, which tells us what user wants, but this is latent, it's unobservable, and actions which represent what system says. And the idea is that because what user wants is unobservable, we need to keep track of the distribution over all possible states at every dialogue turn. Now, this of course leads to huge computational complexity, but there are, and it creates difficulties for both belief state tracking and policy optimization. And there is a lot of work that was looking at how to actually do this for a real system. So I have here a reference if you are interested in. The problem, however, is that even today, that the dialogue state trackers, if measured on on the accuracy, they still perform better than belief state trackers. Though I think at the very last ACL there was a very interesting paper which tries to do belief state tracking for dialogue using neural approaches that seem to perform as well as dialogue state trackers in terms of accuracy. So yeah, there is a movement in the right direction there. Okay, so the sixth point I want to talk about is building blocks of dialogue system. Now, traditionally, dialogue systems are built as a pipeline of modules. So we would have automatic speech recognition, and the output of that would be passed to natural language understanding and dialogue state tracking, which would then utilize policy to find the right action that would then be generated by natural language generation, and finally passed to speech synthesizer. Now, if you view a human brain as a giant neural network, it's reasonable to think that we can produce an artificial neural network which takes words as input and produces output. It is, of course, different regions of brains are responsible for different things. And of course, even if you build a neural network like this, you might decide that different parts of it are doing different aspects of dialogue modeling, and that is not a problem. The appeal of this approach is that you can potentially propagate gradient between different modules, and this is something that traditional approach simply doesn't do. And also you can potentially utilize large amounts of unlabeled data. There are, however, in practice many problems. And one particular problem is that oftentimes people only consider sequence-to-sequence models and effectively only do the tracking part and do not incorporate planning. And one of the approaches that actually does incorporate planning into an end-to-end system is given here. It's called Rethinking Action Spaces for Reinforcement Learning in an End-to-End Dialogue Agents with Latent Variable Models by Zhao and colleagues, and was published at NACL last year. So there is definitely movement in the right direction, but I urge you to have a look in the paper, and then you'll see that there are actually very many difficulties to overcome. The 7th point is actually a quotation from Wittgenstein, that the meaning of a word lies in its use. So traditionally, dialogue systems were built using symbolic representations for concepts that are represented in the ontology. So this is typically domains, slots, and values. This means that then if you want to utilize machine learning, you would need to have labeled training data with these symbols. You oftentimes need to perform delexicalization because you don't typically have enough training data for every particular occurrence of your symbol. And then the problem is that we cannot associate words which aren't seen in the data with these symbols. And another problem is that symbols between themselves do not encode any similarities. So here on the left side, if we have symbols for cheap, expensive, and affordable, they will be equally dissimilar to each other. Distributed representation, on the other hand, or word vector embeddings, utilize large unlabeled corpora, and this is something that is very, very useful. And also, we can calculate semantic similarity between words because the idea is that similar words with similar meaning are close to each other in this vector space. So this can remove the need for the lexicalization and can have better generalization capability. So for example, if you haven't seen affordable in your training data, but you do have word vector embedding for affordable, you can find that it's very cheap, very similar to cheap, and then the system can still operate on that. So for this, I picked work by my colleague Nikola Merksic on counterfeiting word vectors to linguistic constraints. Okay, and then the next question is, am I doing well, or is my system doing well? And how do we actually evaluate dialogue system? Well, this is in a way an Achilles heel of dialogue research, because on one hand we have some automatic measures at hand like Blue, Rouge, and Meteor that are appealing because of their simplicity, but they can often be misleading and do not correlate well with user satisfaction. Success or completion rate measures how well the system can fulfill the user goal and is really indispensable for task-oriented dialogue, but it's not always straightforward to compute it. User satisfaction is very important, but is very difficult to measure and can have very high variability. We also need to take into account efficiency measures for task-oriented dialogue, such as number of turns and response time, but obviously these will be different from task to task. When we think about generation, additional measures to consider is naturalness, informativeness, fluency, and readability, which is fluency in context. And here I picked obviously the work on Paradise and also evaluating measures for generation by Stent and colleagues. The 9th point, I'm talking to you. Actually, what we are building is a user-centric technology, and we need eventually to have the human in the loop, either for training or at least for evaluation. And typical setting for evaluation would mean that we recruit volunteers, produce tasks for them, and let them talk to the system. In-lab testing can be very laborious and can only collect, in this way you can only collect a small number of dialogues. And one way to scale up is by crowdsourcing, which I already mentioned. But I want to single out one really nice initiative from CMU, which was the Let's Go challenge. So Ravenclaw dialogue system, which I have the citation here for, was connected to a Pittsburgh bus information phone line after working hours. And people could call the system and ask, for example, when is the next 61C arriving? And these dialogues were then provided as the training day. This I think took place over several years. And the dialogues that were collected in this way were provided as training data for systems in the challenge. And then the best performing systems were connected to the phone line. And the results were really interesting and sometimes unexpected. So here is the citation from the challenge as well. So for example, it turned out that during this time there was entrainment taking place. So the users simply got used to a particular way of speaking to the system that they were that would maximize the chances of them getting the information. But what is really important to note that this is a real user experiment. So these are not paid volunteers. These are people who have the actual need to find information. And this is something that doesn't happen very often. A similar experiment was done on Alexa Challenge a few years ago that I already mentioned. But what is important in such settings to think about, and especially if you're training from crowdsourced users, is that we are dealing with unreliable user input, or the user input with a very high variability. And we oftentimes need this rating to rate our systems, but also possibly to train our systems with. So here in this work, my previous colleague, Sue, was working on a Gaussian process model that would effectively model the uncertainty of the user rating, and included that in an active learning framework so that we would only query the user when we would think it's absolutely necessary to know the user output. And in this way, I found that this is actually more stable than querying the user all the time. So it removes, to a certain extent, the noise that comes from the user label. Okay, and the final point is, of course, there is no data like more data, and we need to think about the training and testing corpora that we use for our dialogue system. There is a very large corpora available for chit-chat, which is not labeled, and very small corpora for task-oriented dialogues. For multi-was setup, we need substantially more data. And Wizard of Oz setup is one way of collecting more dialogue. So what does Wizard of Oz setup mean is that you would effectively have two humans talking to each other, and one would play the role of the system and the other would play the role of the user, and they would not necessarily know that they are not speaking to the human. So similar in a way to the Turing test setup. And they would be producing dialogues in this way. So what my team in Cambridge did 2 years ago, we collected a large multi-domain collection of dialogues in this way. And here you can see some statistics of how it compares to different corpora at the moment. So I think DSTC2 was very popular because it's actually it's based on speech transcriptions, so it contains noise in the user input. But all of the other corporas are quite small in comparison to multi-was. So currently multi-was is used as the standard benchmark for various parts of dialogue modeling, in particular dialogue state tracking. Okay, I want to leave some time for questions, and just going to quickly round up that dialogue requires much more sophistication than simple sequence-to-sequence models provide, and there are important lessons to be drawn from previous approaches, even if we don't utilize these approaches anymore. And there is still a lot more that we need to achieve. Current state-of-the-art approaches are wrong almost every second turn. And the available label data is still very, very small given the difficulty of the problem. And we are building user-centric technology, but evaluating it on measures such as blue, so we need to rethink this as well. Reinforcement learning is very promising and has been part of this this area for a long time, but it is difficult to have it in an end-to-end setting. So this is something we need to work on, and the list can go on and on, but I will stop here and take your questions.
Well, listen, thank you very much. That was a nice talk. Alex, would you like to come on as well to the stage and questions?
Hi. So I have questions, but rather than ask them immediately, I'd like to ask the audience, the attendees, if they have a question. So one way to do that is to raise the little blue hand in the participants display at the bottom. Is that true?
Yes.
Okay.
By the way, Milica said that if you don't ask questions, she'll ask you questions. So you better.
Uh-oh. Okay, in that case,
the audience, yeah.
I have a question. So as you point out, one of the problems with these kinds of statistical models of dialogue is there's not enough data. And there's been various attempts to kind of sort of get around that and introduce, well, make better use of data, introduce context, and so forth. So I can think of two. One is hierarchical systems, and another approach that's been tried is to essentially cluster states that have similar behaviors in a dialogue and to pool the data across those. Do you think that's a direction? It hasn't really been totally successful in terms of adaptation, but I'm wondering what you think is.
So I think hierarchical approach, I mean, conceptually makes perfect sense. The problem is that you require, the actual implementation requires like a designer decision at which point to make the hierarchy, to actually define the hierarchy. And that in itself is limiting to a more widespread, I think, use of hierarchical approaches. I haven't seen hierarchical approaches that do not require human intervention. I've only seen, actually this was at the last ICML, a paper that was doing this for a general variational encoder to try to extract basically the latent state information at various stages. And maybe something like that could be utilized further for dialogue state tracking. But I'm not aware of anybody who has yet done that. And the second issue is clustering. So I think clustering can help, certainly. The problem is that it relies on the measure of similarity. And that is something that is particularly hard for word vectors because they don't always encode similarity in the way you would want it to. So for instance, they typically encode, vectors would be similar that have similar contexts. But for instance, in dialogue, if you think of restaurant information dialogue, things like north and south would have exactly the same context, but completely different word vector would have exactly the same context and therefore very similar vectors, but they actually have different meanings. So this is something that one needs to look into in order to apply these methods, I think.
Thank you. So we have more questions. So I'm not sure what the order is because I wasn't glancing there.
Just go from the top, Alex.
Okay, Mari, please ask your question. Okay,
thank you. Very nice talk. I always love hearing you. I have a question about, I'm glad you mentioned user-centric technology. I think that's really important. And beyond, and of course that has a big impact on value evaluation. I think it also has an impact on reinforcement learning. And I was wondering if you could, the issue of variation in what makes a user happy and the things and their goals. And so I was wondering if you could comment on that at all.
Yeah, so this was, I very briefly talked about this work. I think this work is really dealing with that in some sense, that it is trying to view the rating as a latent variable over which we have some probability distribution, and only really ask for feedback when the model itself is uncertain about the rating, and not consider user rating if it's very far from a very certain model. So, and of course, this is only done on success prediction, but I think it can be extended to different aspects of learning. I think we have to somehow come to terms that we are dealing here with latent variables, and that simply there is a lot of noise in the use, not only in the user input but also on the user rating, and that the way we exploit that for learning, and in particular for reinforcement learning, has to somehow take that into account. We will always, for instance, to train a dialogue system, a simple restaurant information system, you would need between 2,000 and 10,000 dialogues, and you're very likely in this 10,000 dialogues to have some users which are really misbehaving or not providing reliable reward, but the system needs to be robust to that, and it needs to it needs to be able to notice that. So really, a representation of uncertainty is very very important.
Thank you very much. I think we have Derek Chen next.
Yes. Hi, this is Derek. I'm an AI researcher out in industry right now. First of all, great talk. Always great to hear from you. Actually, my question actually follows a little bit on what you just mentioned, which is the problem of dealing with this uncertainty. So my thought is that one way to deal with this in terms of mitigating the problem is through interactive dialogue. And so rather than trying to craft a perfect reward signal, maybe a good way to deal with it is to ask good clarification questions back to the user. What do you think about this type of direction? Is it like a promising way to move forward? And if so, are there any past works or future papers that you're looking at that might be good to follow up on?
Actually, there is a very good paper in past to look on this. It's by Finale Doshi and Stephanie Sennett from MIT. I think it was something like 2004 or 6. I don't remember exactly the date, but it was looking exactly that. So utilizing dialogue as a way to reduce uncertainty, so yeah, I'm totally, I agree with you that this is also something we can look at. What is important though to stress is that we will never be able to completely reduce uncertainty. Uncertainty will always be there, and uncertainty exists even in human-human communication. But the idea is to manage it in some way that it is pleasant for the user, and certainly asking endless questions to the user, it's not pleasant. So that is, I think, the trade-off that needs to happen.
That makes sense. Could you just repeat either like the author or the name of the paper?
So I will find the paper, and so it's Finale Doshi is the first author. Yes.
Thank you.
And this, yeah.
Thank you. I want, since I have voice, let me add one thing. We've tried asking people those kinds of questions in a crowdsourced environment, in particular Alexa Prize. And we discovered, to our chagrin, that people tend to ignore you. Some might say something usually not very helpful. Most people just go on. And the other comment is, in the past, we did look at not so much active interaction, but noting that something went wrong and the user said, basically corrected or said something else, and using that information as the feedback. So they did not need to initiate the feedback, but nevertheless their behavior provided that. Anyway, sorry for interrupting that. So now we have a question from Christina Jokinen.
Can you hear me?
Yes. Hi, Christina.
Yeah, hi. Thank you very much. I mean, that was great talk. I have actually two questions. One is related to multimodal aspects, because I think we also have this kind of extension of dialogues related to gesturing, different types of picture generation from pictures, etc. So how do you see all this kind of multimodal information in the this sort of dialogue context that you were talking about?
Yeah, so I mean, this is one thing that I did not include in my talk, simply because it's such a big area, and there would be one can make the whole talk about it, but I think it's very so there are obviously things like engagement and other aspects of multimodal communication and embodied communication. But if we think about state as well, we can also look at the embedded representation of images and similarities between those and how those are encoded. And actually, I think the space that images produce, that embeddings of images produce, is much more regular than word vector space. So that's, I think, a good thing. And my feeling is that some of the methods can be more successful there in terms of adaptation capabilities, for instance. What is difficult, of course, is that we are dealing with somehow asynchronous inputs, and associating words with images is then the challenge, I think.
Right. Thank you.
Thank you. Oh, sorry.
Yeah, can I just, the second question I had is a kind of a continuation to this, if I may, because I was thinking you also mentioned that we need to somehow learn from some previous expertise and so on, and I was wondering how you actually see the future of dialogue systems, and how we can actually get this huge knowledge that we already have from about, say, turn-taking and engagements, and then also about the multimodal information into the dialogue system. Do we need just simply more data, or clever algorithms, or some better representations, or what is your view of the future concerning this type of things?
Well, I think, I mean, at some point we will exhaust the current methods, I think. I mean, of course, with more data, we can get more accurate and better methods. Yeah, we probably do need more data, but I think a more pressing issue is what are actually our algorithms capable of? Because, I mean, if we learned a lesson from speech recognition, for instance, so, I mean, Sanjeev or others who know about, who are experts here can correct me, but basically, current speech recognition systems hear more data than I mean, are trained on much more data than a real human encounters during their lifetime. And surely there is something about the way we process this data that make us being able to be so efficient about it. And I think this is very much, how to say, exacerbated in dialogue, because I mean, we can't possibly collect all the data that we need for the current models to perform well. So we do need to look for that solution to how actually to utilize the data that we have in the best possible way. And what is actually the data that we can learn from? Is it really just the labeled dialogue data?
Thank you.
Thank you. A quick interjection. A number of researchers recently have tried to approach the problem by, in the context of neural net training, breaking down systems into modular units reminiscent of the symbolic approach. And I think the idea there is to make the training problem a little more tractable. On the other hand, it's, I don't know, what do you think of those approaches?
Sorry, I didn't hear, make the training problem?
So if you take, people have done end-to-end systems, and in particular for conversational speech, they don't work too good. And one of the reasons is you don't have data. In the goal-directed sphere, people have tried things like breaking up the system into a bit that does, well, speech, NLU, dialogue, and so forth. So to me, that seems like trying to reduce the complexity of the problem to fit the data. Is that true, or do you think there's
reduce the complexity of the problem? Well, I think I would more see it as providing the system with more supervision, because you're providing the supervision signal from the understanding module, you're providing supervision signal from the tracking module, you're providing it from the dialogue action potentially if you're not using reinforcement learning. And usually the supervised training approaches are, I mean, do not require as much training data. So I think that's the effect.
Great, thank you. So we have a question from Thomas Schaff.
Thank you, Milica. That was a great talk. Actually, I have, I think partially you already answered a little bit of my question that's coming right now. My question is more centered around human-to-human conversations, dialogues. So I would like to know what your thoughts are on systems that follow actually a human conversation and try to summarize them. In my context, it would be doctor-patient conversation, but also think about meeting notes and provide information to support such conversations, right? So in particular, do you think modeling such conversations as the dialogue system is appropriate? And it sounds like, at least from the technology that is currently available, this might be a big challenge. Because these are pretty...
To model it as a human-machine, the way we model human-machine conversation, is that what you're saying?
A machine that is part of a human-human conversation.
Yeah, that is your task, but you're saying?
Well, do you think it's appropriate to approach this as a dialogue system problem, right? So build the machine using dialogue, state tracking, and these kind of things.
Well, I know that it, so I think in theory that would be the right thing to do. But I think in practice, you actually end up having a lot of problems, mainly because of the first point that I mentioned, which is that people don't seem to make such a strong, they don't really distinguish between the task-oriented and social dialogue. And you will have a lot of noise in that sense if you just try to do this in a sort of state-of-the-art dialogue, modular approach to dialogue. I mean, maybe with the current performance of, and also, I mean, if you look at current performance of these dialogues, even on a very restricted, these dialogue systems, even on a very restricted task, like multi-domain attraction kind of tourist information system, that means that there is still some place to go. Though I would be very interested to see actually how it works for your task. So I guess I would be curious to try, but I wouldn't have my hopes very high that it would actually work particularly well.
Yeah, just to interject with a sort of an outsider's perspective, I think what Thomas is saying is, like, you know, it's taken us a lot of effort to just get out of goal-directed dialogue and think about social dialogue between like two parties, right? It's you and your intelligent device. What Thomas is saying is, let's push it one level further. Let's have a multi-party, three-person social dialogue where two people are talking and your machine is the third party to the conversation.
Yeah,
and somehow
but
it's
not entirely social, because it has a goal, right? It's about patience. So
Thomas has a goal, but I think the general problem is a three-way conversation.
Yeah.
All the parties are trying to achieve something, and maybe
there is, I mean, there is a lot of work in multi-party dialogue as well, which I also omitted from my talk.
Okay.
But
so maybe you can say more, and that might help Thomas.
Yeah.
So I have an interjection as before. So we've been working on the problem of conversation, and thinking about it as it's a mix of social goals and possibly task goals. In particular, something we call a blended system that has components which maintain, essentially build and try to maintain a social relationship, and another bit that actually does whatever task is at hand. In our case, it was negotiation. So I think kind of the social stuff there are goals. They're just different kinds of goals than the ones we're used to. And I think the trick is to understand how a multi-goal
and probably they are latent as well, right?
I'm sorry?
And they're latent.
Yeah. So let's see, we have 1 minute.
Yeah, Alex, let me throw in a question that I had based on a little exchange that you and Milica had. So you started suggesting that perhaps the reason we train these things in components, and I know the speech recognition part, and there's a synthesis, there's maybe extracting elements of information from the turn, tracking the state. And you're saying that this is done more to manage data because you have lots of data one for the other. And Milica came back and said, no, this is also to provide supervision. Like, you know, each intermediate stage gets its own little supervision. I'm wondering, however, if the supervision is what makes these things brittle, in the sense that you force the system to learn how to parse a turn to extract something from it, and therefore it focuses on that as opposed to something else. So I'm wondering whether to go to more conversational, more general dialogue systems, you'll have to break that and let the system produce some kind of latent internal representations that are not supervised in order to accomplish the goal of the dialogue, if there's a goal, or to just sustain the dialogue, if it is checked.
Yeah, I think that's an interesting point. And I will answer it from a different perspective. I'll answer it from a perspective of a mom of an 8-month-old baby. I was talking to my husband recently, and I told him that I really don't think she learned anything from us. I really think that everything she learned by herself. I mean, we don't crawl, we don't say these nonsensical words. We don't. She produces sounds that we do not produce, and somehow she really does things on her own. And I really feel that a lot of human learning is actually takes place in a quite this unsupervised or reinforced, and not so much supervision takes place. But currently the supervision is, I think, the only way we can overcome this problem of data limitations. So I don't have a good answer to your question of how we actually do this in a better way.
So I think that's an excellent point. I think about what happens between an infant and let's say a teenager, and one of the things is they're basically collecting data every day for 10 hours or 18 hours. That's an amazing amount of training, and they do get reinforcement from the world. So if you say "mama," then you get a big smile out of the female adult. If you say "grew up," then something else might happen. So it really does come down to data, but also reinforcement and what I would call implicit supervision. What would be really cool if we could build systems that you don't painfully collect data and train, but actually set them out in the wild for a year or two and see what happens. That would be great. Anyway, so
Alex, I think you get the last question.
Oh dear.
Or you get
well, that was the last comment. I have questions, but I think we did okay. So I'd like to thank Milica for a really great talk, and thank you all for showing up. And now Sanjeev will take over.
Thank you, Milica. Thank you very much. If this had been a physical workshop, we would have all taken you out to lunch now and the team and so on. But I guess we'll have to say thank you, and we'll hopefully have you in better times visit us in 3D, and we'll continue this dialogue. Alex,
thank you very much, and thank you all for your questions.
Thank you. Bye-bye, everyone.
Bye.